Jupiter's biggest moons were discovered 400 years ago by Galileo. Io, Europa, Ganymede, and Callisto are each fascinating worlds. Some could hide oceans that could hold life. Now, NASA claims that the Juno spacecraft has detected an FM radio signal coming from one of these giant moons. Where did this signal come from? How did NASA find it? And what other secrets are Jupiter's other moons hiding? We saw your comments about wanting to hear more about the strange FM signal coming from one of Jupiter's moons, and now we've delivered just for you. Enjoy! Something recently happened that caught everyone's attention. NASA's Juno spacecraft is still out there wandering space, and for the first time since it was launched, it picked up an FM radio signal coming from Jupiter's moon, Ganymede. This is the same kind of signal that you would find here on Earth. In fact, we use this signal every day and know it as Wi-Fi. Did we just pick up an alien radio station broadcast from Ganymede? To figure that out, we need to know more about this icy alien world. Ganymede is the largest moon in the entire solar system. If it was orbiting the Sun, it would be a planet itself, being larger than Mercury. Although Ganymede doesn't have an atmosphere, it's the only known moon to have a powerful magnetosphere, which sometimes produce auroras that are affected by the moon's underground saltwater oceans. The rocking seen by the auroras gives researchers evidence that the underground oceans on Ganymede are possibly liquid and very salty, far saltier than the Earth's oceans. The FM signal that came from Ganymede originated from electrons in electromagnetic fields, a process causing the electrons to whirl and oscillate much slower than their spin rate. The Juno spacecraft detected the 5-second radio burst in late 2020, when the moon crossed a polar region of Jupiter where the gas giant's magnetic field interacts with Ganymede. So could there be life on Ganymede? Well, we know for sure the signal didn't originate from alien life. It's also very cold on Ganymede, with temperatures around minus 186 degrees Fahrenheit. However, during one of its flybys, the Galileo spacecraft detected a dense stream of atomic hydrogen escaping from the moon's very thin atmosphere. This means that there are large amounts of oxygen that's locked up or hovering over its icy surface. Atomic hydrogen is the lightest atom, and Ganymede has a weak gravitational field, so the hydrogen escapes and the atomic oxygen stays behind. Some researchers say that Ganymede could have as much oxygen on its icy surface as the Earth has in its atmosphere. So could Ganymede have everything for life to exist in its subsurface oceans? Some scientists think the pressure at the base of any ocean here would be so high that it would turn to ice. But a mission is needed to find out more. But this moon isn't the best candidate for life. In fact, there is another moon orbiting Jupiter that some scientists are calling the most habitable place inside our solar system. Europa is an icy white moon with brownish streaks on its surface and has an icy crust that could be from 2 to 20 miles thick. It's the smoothest surface of any other object in our solar system, and you wouldn't find any mountains or craters here. Underneath the icy surface would be a vast underground saltwater ocean, which could be twice the volume of those on Earth. Europa is very cold, with an average temperature of minus 260 degrees Fahrenheit, which keeps the icy crust as hard as granite. But could life still exist here? It's possible. At the dawn of the space age, it was thought that all life depended on the sun, and any object too far from a star would be a frozen ball of ice unable to support life. But finding thriving ecosystems at the bottom of Earth's oceans relying on hydrothermal vents changed all that. Now we know life is pretty tough, and it can survive completely isolated from the energy of a host star like our Sun. It's important to know this because Europa could harbor simple microbial life in liquid oceans underneath its icy crust, and this life could be surviving off the same kind of hydrothermal vents. So how do we know that Europa probably has liquid water needed for life to thrive? The Galileo spacecraft that flew over the moon in the 90s uncovered evidence of a vast, deep, dark, global subsurface ocean. Even though the moon should be a solid ball of ice, the water on Europa doesn't freeze completely because it's constantly churned by powerful tidal forces as the moon orbits around Jupiter, and at the same time, those tidal forces cause Europa's core to generate heat. Scientists are excited because this global ocean is thought to be in direct contact with surface ice and the moon's silicate mantle. This brings together everything needed for a habitable environment: liquid water, a source of energy, and a source of minerals and nutrients that life needs to flourish and survive. We know some bacteria or extremophiles like tardigrades can survive extreme environments, and just maybe, Europa's hidden ocean could have these kinds of life forms. Between 2014 and 2016, researchers got evidence that there might be liquid water on Europa. Hubble Space Telescopic images showed evidence of huge geysers of water vapor, some 62 miles high, erupting from the surface over Europa's south pole. Although some researchers aren't sure, we're going to find out soon enough. NASA wants to send a probe to Europa by 2025. The spacecraft is called the Europa Clipper, and it will explore whether this icy moon has conditions suitable for life or not. The $2 billion solar-powered probe will fly by Europa 40 to 45 times using a number of high-tech instruments to study the moon's icy shell and the ocean that's underneath the surface. Will it find life? Only time will tell. And what about the Jupiter moon Callisto? Is it possible life could exist there as well? Callisto is the second largest Jupiter moon and the third largest moon in the solar system. It's almost the exact same size as Mercury, but with a surface temperature of -218 degrees Fahrenheit. It was once thought to be a dead moon because of its ancient cratered surface. In fact, it has more craters on its surface than any other object in our solar system. If you have many craters on the surface of any astronomical object, it means that geological processes are probably dead. But Callisto also orbits too far away from Jupiter to be affected by the gas giant's magnetosphere and heavy gravity. However, Callisto may also have an underground ocean, and the satellite's icy crust might be acting like a cosmic blanket, insulating this underground ocean. It's not clear whether this ocean could hold life because the surface is so old. The only way to find out for sure what's happening on these icy moons is to send a probe. NASA and the European Space Agency are building the Jupiter Icy Moons Explorer, or JUICE, which is planned to launch sometime in 2022 and begin a 7.6-year cruise to Jupiter, arriving sometime in 2029. We've all heard about the James Webb Space Telescope and the amazing potential it will have to find habitable exoplanets. But the JUICE probe is going to be carrying the most powerful scientific payload ever flown to the outer solar system, which includes 10 state-of-the-art instruments, plus will perform an experiment using the spacecraft telecommunication system with ground-based instruments. During the first part of its 3.5-year mission, the JUICE probe will make 30 observation overflights of the 3 icy moons Callisto, Europa, and Ganymede, studying them in close detail by examining their gravity, magnetic interactions, and checking to see if liquid water really does exist under the surface of each one. It'll then investigate whether these oceans might hold the organic components necessary for life, or even life itself. There's another interesting moon that's been grabbing the attention of researchers lately, but it's not in Jupiter's orbit. However, we think it's worth mentioning if we're going to talk about finding life in the solar system. In 2019, NASA revealed the ocean on the Saturn moon Enceladus contains the building blocks for life. This vast water ocean is about 6 miles deep and lies under an icy crust that's 19 to 25 miles thick. Images of huge plumes of water vapor erupting through cracks at the south pole of Enceladus were captured by the Cassini spacecraft and indicate there must be an underground ocean. These plumes were analyzed by the folks at NASA and found to contain water vapor, ice, salts, methane, along with simple and complex organic molecules, the kind of stuff normally found in living systems. The newest study of Enceladus shows the moon is more geochemically complex than previously thought, and that carbon dioxide is being controlled by chemical reactions on the seafloor of an interior ocean, boosting the chances of the moon having some kind of life. On Earth, oxygen-breathing creatures consume energy in organic matter like glucose and oxygen to create carbon dioxide and water, and oxygen-breathing microbes can metabolize hydrogen to create methane. NASA's Cassini's Ion and neutral mass spectrometer detected methane, carbon dioxide, ammonia, molecular nitrogen, and molecular hydrogen in the plumes. And molecular hydrogen would indicate there is free energy available in the oceans of Enceladus. Cracks in the ice where the plumes erupt have temperatures warm enough that seems to show the ocean is being heated by the moon's core. These hydrothermal vents could be similar as the ones found on the Earth's oceans and are hotspots for life. A team of scientists now want to send a probe to the moon to find out. It's called Orbilander, which would cost $2.5 billion. The probe would orbit Enceladus for 200 days, which won't be easy considering Saturn's giant gravity field. Orbilander will fly through these plumes of vapor, which will then funnel into science instruments at high speeds. But this probe won't only orbit the moon, it'll also land on the surface, and so it will need to find the perfect place. Once the location is found, the probe will convert to a lander. 2 nuclear power sources will keep Orbilander running on the surface of the moon for up to a year and a half while it sends data on what it finds back to Earth. The chances of finding life out there somewhere seems to become more possible, and with these exciting new missions, amazing discoveries are going to happen. So make sure to stay tuned here.